Sorry, I need to interrupt. You've lost your audio connection via live meeting. Can you please check? And the phone line, mute, please.
Yep. So now can you hear me?
No, still not.
Now it should be.
Yes, it's back, and please put your phone line *5.
Yeah.
Sorry.
Okay.
And please
No problem.
start again with page 15. Sorry, all attendees.
Yeah. Okay, I'm sorry too, but I couldn't hear whether you hear me or whether you don't hear me. So thank you, Chantal. Okay, I go back to the substances not included in the union list, but still covered. So mixtures without chemical reaction respect the limits of the single substances. However, if a mixture is authorized, the individual substance is not necessarily authorized. Polymeric additives, if they could be used as a polymer to manufacture an article, then covered by authorization of monomers and have to respect the monomer restrictions and specifications. Polymeric starting substances, if their monomers are authorized and have to respect the monomer restrictions and specifications. Salts, as mentioned before, now there are more salts which are authorized in regards of acids, phenols, and alcohols. They may be used even if not especially listed in the Annex 1. But of course have to comply with general limits in Annex 2 for certain cations. Substances not included in the union list and not covered. Colorants. Colorants have not mentioned in the union list. Still, there are some colorants like titanium oxide, which are in the PIM from historical reasons. But generally, colorants have to comply with Article 3 of Framework Legislation 1935-004 and national law. Then aids to polymerization, like catalysts, chain transfer agents, etc. They are not mentioned as well in the PIM. Solvents need also to comply with Article 3 of 1935-004 and national law. Polymer production aids are listed, but others can be used in accordance with national law and risk assessments by the manufacturer. And again,
Jürgen, sorry, I have to interrupt again.
Yep.
All listeners via the phone line, as a backup, can you please press *6 to mute your phone lines? There is a lot of background noise.
Yeah,
Jürgen, can you please try again *5?
Yeah, I tried it 10 times. I cannot mute on this *5. It's not
Okay.
possible.
Okay. So please, people who listen in via the phone, can you press *6? There is a lot of background noise. Thank you.
Okay. Again, I start with this page. Substances not included in the union list and not covered. So still it's a closed list. There's still some exceptions because those substances have not yet been evaluated by EFSA or the European Commission. First of all, the colorants, and of course all those substances and material substances have to comply with 1935-004 and, if possible, if listed with national law. Same is for aids to polymerization, catalysts, chain transfer agents, etc. Solvents, polymer production aids, and of course the so-called non-intentionally added substances, the so-called NIAs. NIAs are impurities, unintended reaction products, decomposition products, which are present, but which are not intended to be generated. Specific requirements. General migration levels for heavy metals. General restriction for primary aromatic amines. Clarification on status of substances in nanoform. Substances in nanoform can only be used when they have been subject to risk assessment and authorization in this form. So, on a case-by-case basis. Now, let's go to the next point on our agenda, the specific and overall migration. Can I please again ask everybody to go on mute, because I cannot mute from here and there's still background noise. Thank you very much.
Jürgen, your headset is lost again.
Okay, can you hear me?
Fine.
Should be possible. Okay. OM2, long-term storage handling, including short-term heating. That's very important because it's 10 days 40 degrees and it includes short-term heating because often there is made a hot fill. OM3 is covering 2 hours at 70 degrees for short-term heating. OM4, high temperature application at 100 degrees. And if it goes up to 120 degrees, 2 hours at 100 degrees or at reflux 1 hour at 121. And if it still got higher than that, then 4 hours at 100 degrees or at reflux or 2 hours at 175 degrees. Which is meanwhile very relevant because meanwhile there are a lot of, or at least some plastics which are can withstand more than 200 or even 230, 240 degrees. And as you see, there is none of these simulants can really stand this temperature. So that's why you have to take a long time, like 2 hours at 175 degrees, even if your application is shorter. Now we have a look at the overall migration limit. Again, it's looking for inertness for a limit, and the limit is 10 milligram per square decimeters. Why per square decimeter? Because on the right side, this is a try to give you a picture on what was the thought behind it. The thought behind it is the so-called Eurocube approach, which means that 1 kg of food is packed by a dice of 1 decimeter length, so meaning 6 square decimeters. And if you look on the area, which you often measure, then it's 1 square decimeter. The overall migration limit is only in food stimulus A and E. It does not cover volatile substances. It's expressed per food contact surface area, of course. And for infant foods, expressed per kg of food. Specific migration limits are set out in Annex 1, not for all substances, but just for those substances where scientific evidence has shown that it is necessary to restrict the migration. If there's no SML specified in Annex 1, then a maximum of 60 ppm is applicable. The SML is related to food. All other testing with simulants is just an approach to ease our testing. So if you're not compliant with a substitute, then you can still measure on food, and if you're compliant there, then you're compliant. Another point is very important. There are substances which can be used in food contact materials and in food direct additive in foods. Those substances are called dual-use additives. And of course, the lowest restriction applies for authorized food additives. For the specific migration testing, this table gives an overview on the contact time in foreseeable use and the corresponding testing time. So you see, if your contact time is very short, you need to test only short. Interesting and new is if you go on the low end, what is here marked in red. If you are between 3 days and 30 days, it's 10 days. If you're above 30 days, there are specific conditions. The second part, of course, of this contact, and very important for the transfer between the two phases, plastics and the food, is the contact temperature. Here as well, a table is given. So if you're below 5 centigrades, it's 5 centigrades. If you're below 40 centigrades, it's between 20 and 40 centigrades, it's 40 centigrades. So always the highest, of course. And if it's above 175, you need to adjust as much as possible the temperature to the real temperature at the interface with food. So let's go to the long-term conditions, the so-called special conditions. So there are 3 alternatives given. Alternative 1 is the use of the Arrhenius equation, which is given in the PIM, which I don't want to go into detail now. Alternative 2 is frozen conditions 10 days 20 degrees. Refrigerated 10 days 40 degrees. And the storage below 6 months means measuring at 10 days 50 degrees and above 6 months even at 10 days 60 degrees, which enormously enhances the migration. This has been shown by testing. Alternative 3 is you still can use 10 days 40 degrees if scientific evidence shows that equilibrium is reached after 10 days. So let's come to a very interesting point, which has been came more into discussion since now we have the year 2013, because the old testing parameters were valid until end of 2012. And the next transitional period is between 2013 and 2015. What is very interesting and very important, and I think that's the main point of discussion, is until 31st December of 2012, old simulants could be used. And if you go in the old simulant directives, there is a table which gives you conditions for substitute testing. And the conditions for substitute testing can deviate from solvent to solvent. If you use isooctane, which is a very strong solvent, you need to test at lower temperature and less time. So for 10 days, 40 degrees with isooctane, you could test 2 days at 20 degrees. And for the alcohol, it's as well 10 days, 40 degrees. So this shows why it was very convenient to take isooctane. However, even in the old directives, it was said if the test is negative, you have to use with the original food simulant, with olive oil. So verification of non-compliance can just be with olive oil. As from December the 31st, 2012, the new simulants are applicable. So no isooctane. It's just mentioned in the PIM for one specific case. But for other cases, it's no more listed. However, you can use screening methods with the testing in the PIM, and therefore isooctane can be used, but not for verification, and there's no list which shows comparable test conditions anymore. In addition, these transitional provisions are handled differently by authorities and industry. So while it was until end of last year, the old conditions should be used, it's now until end of 2015 that either the new conditions or the old PIM conditions may be used. However, the authorities use the new conditions. And of course, as from January 1st, 2016, when the transitional period is over, just the new conditions can be used. And what was very interesting, I discussed with authorities of Stuttgart in Germany, say that if you provide your testing on request, if they look at your company and want to check whether you have good supporting documentation, if they see that you have tested according to the old conditions, they will make their backup testing to check your tests with the old conditions too. But if you don't provide that, because you don't have it, or you didn't think of it, then they look with the new food simulants, with the new contact times, with new temperature conditions, as from beginning of this year. This was a very interesting information, because verification can only be made with the new conditions. Let's go to the NIAS, the non-intentionally added substances. This could be, as mentioned, impurities, reaction intermediates, decomposition products, contaminations. Those substances we don't want to have in it. But they are there. And what is important, we don't even know what substances are there in most cases. So it could be a few, it could be 100, it could be 1,000. They can be there in high concentrations or in very low concentrations. And the very interesting thing is, from the PIM, the risk assessment is the responsibility of the manufacturer. And this needs to be performed based on internationally accepted risk assessment principle, which is including hazard assessment and exposure assessment. So what does this mean? This is very general and is not much regulated. So how can it help us? It helps us that it's general, because then it's up to us how we are going to make the risk assessment. Of course, it has to be according this gives us the chance as industry to make our own risk assessment. Of course, we need to obey internationally accepted risk assessment principles. But what is the level of interest? So once we made a screening on the substances to know whether they are there or whether we don't need to care, we at least need to do some screening to have some peaks. Then, of course, we could have high or low concentration peaks. So the level of interest above which substances need to be considered need to be established. The first point is, are those substances known and evaluated substances? Then a given limit can be applied. But how do we know that they are known? We know, for example, because we know byproducts which can be generated during the formation of a polymer. Usually the byproducts of generating a PET, a PE, a polystyrene, they are known. And of course, we know where they come in the GC. So we can say these are those products. Then we come to the not known substances. So here, because we don't know whether they are dangerous or not, a very low limit must be considered. And if we are not sure, we need to identify and quantify them. This can be a long-lasting and very expensive thing. And one has tried to get a little bit more knowledge about the substances and to get an approach which is reasonable, makeable, payable. So risk assessment models were developed which help to assess realistic exposure to the materials used and therefore also to the impurities. There are now two major exposure models. One is already available, but only to a certain group because they have paid for it. It's the exposure matrix model. The second one, the FACET model, it's finalized, but it's still in the testing phase. So reasonably, it can be reckoned that it will be available end of this year. What do those models do? They were taking two things into account. They were taking the daily warehouse on food, which is backed by specific polymers. From that, it was more or less calculated how much packaging is in contact with food, is in contact with human being per day. So maybe PET would have the most impact because a lot of bottles are PET bottles. And PVC, maybe not so much. So it gets a lower number in the exposure scenario. Maybe it's the other way around. I don't have the exact figures. But let's wait on the outcome of the model. The next step, once we have evaluated everything, is the declaration of compliance. The declaration of compliance applies to the final article, but also intermediate stage up to starting substances. It's available at the marketing stage other than the retail stage. And a new DUC should be issued whenever there are changes in the composition or production of the product that bring about changes in the migration. And of course, it's not just sufficient to write down a DOC. You have to have supporting documentation. which is available in-house and where the DOC is based on. Supporting documentation. It needs to be available at all stages and to enforcement authorities only. And of course, it's not just valid for the plastic parts which are contact in food, with food. It's also for non-plastic parts. You need to provide equivalent information that the use for the intended application is safe. So this brings on board all those other substances which are not yet covered by the PIM. Adhesive, printing inks, coatings, colorants. Important on the DOC is as well, it needs to be given through the whole value chain. Of course, it looks different from step to step. For the raw material, you cannot give a final compliance on the product. You just can say that the composition and the raw material properties are right to be used in food contact applications. Then base materials are made of this. From these base materials, they are polymers are produced, they are converted. Then you make defined products like cap closures. Then it's printed, coated, laminated. Then it's packed, and then it comes to the retailer. And in the end, the last step has to take the responsibility. The food packer, the retailer, he has to assure that the health of the customer is not endangered. But of course, the other one needs to support him because he doesn't know what kind of substances are used in the material and what limits should be kept. So upwards, adequate information must be provided through the DOC. And this adequate information, of course, means you need to tell what substances are dual use, for example, what substances have a specific migration limit, that all impurities are covered somehow, and that the raw materials, at the raw material stage, that the raw materials are suitable for use in food contact. And of course, this means as well, before we go to GMP, that throughout the whole value chain, more communication needs to be done than before. So it's important that communication is increased and that you have some trusts upwards and downwards, that you have good relations, that the whole thing works, and because it's up to us all to have high quality food and not to endanger human health. One thing is, which is more or less out of the regulation 10/2011, it's more a thing of the framework legislation, is GMP, good manufacturing practice. This good manufacturing practice legislation, 2022-2006, is only 4 pages long. But the intention is that quality assurance and quality control is done. So that means that there are measures in place that assure articles are produced in same quality and specification. Well, an important point is, at the beginning when GMP came up, a lot of people were thinking on GMP for pharmaceutical products. Meanwhile, this had become better, but still some people don't know the difference. So it does not need to be mixed up with GMP for pharmaceutical products. It's something totally different. Another point besides the quality is the documentation. So this means that for all your material use, you need to have files on stock which show that they are compliant and suitable for food contact. It applies to all sectors and stages of manufacturing, processing and distribution of materials other than raw materials. That's important because raw materials are often chemicals, which are generally used. But of course, in practice, as a downstream user of those raw materials, you need to assure that they are of same quality. What is very helpful in that is to ask for quality standards and specification of the raw materials you're buying. If these are in a certain range, then you can be very sure that they are consistent. Here again, interesting, the details are not given by this 4 pages legislation. The details are provided through a lot of industrial guidelines. Almost every industrial association has a guideline on GMP. But mainly it comes back to those things which are listed here, with giving some more details how to implement it, how to implement measures to control the quality and to assure the quality, how to implement a good documentation system at each step, and how, of course, to implement the next step we want to look at. It's traceability. We come for the next point. What is still a point, another point of the legislation 222/2006, in the annex, there are specific provision for the use of printing inks. Because it turned out that often can be happen if a film is stored in a roll. So the printing from the outside can migrate to the inside. Same thing can happen with the printing inks, that they are migrating through the polymer into the food. And of course, this should be avoided, and this is part of the GMP legislation as well. Now I come to the last point. It's traceability. So traceability is more or less part of this GMP as well. It's the possibility to identify a material or article at each step of the value chain, manufacturing, converting, distribution. One step upstream and one step downstream are the minimum which should be traceable. In further restriction demanded, an enlarged traceability is necessary. And of course, this is not just valid for Europe. This is also valid for those companies which import to Europe. They should be able to trace back as well. And interestingly, how the traceability is assured is again up to the manufacturer. So he needs to have system in place to assure it. Thank you very much for listening. For more information, you can look on the link, Intertek link, and of course, you can contact me. I'm part of a global network of food contact experts in Asia, Pacific, Europe, and America.
Okay, Jürgen, I'm going to help you now with the questions. We have quite some. First of all, I would like to apologize to all participants for the very poor sound connection. We tried to solve it, but it's unfortunately low luck. We need to solve this. Yep. Okay, we will go to through the questions we have so far. First of all, who needs to perform migration tests? Should everyone do this, or only specific companies in the supply chain?
Pardon?
So, who needs to perform migration testing? That's basically the question.
Well, responsible is the end user, that one who brings the final product on the market. That one is responsible that those limits are met and that the material is safe. Of course, it is helpful if you sell a material that you know whether your material is suitable for the use in food contact. So this means if you know that your material is suitable because you did your own tests, then you can say to your downstream user who is using it for packaging food that it is compliant on the basis you tested it and then he can be very confident that his use will be covered.
Okay, so it's basically kind of risk assessment you are performing then.
Yeah.
Okay, the next one. There are several questions basically on the comparison between European and US regulations, referring to the FDA, the California Prop 65, etc. How can you compare this? Can you use them? Of course, we will follow up each question separately. There are quite a few in this area, so we need to pack it into one.
Yeah, it's good that you pack it a little bit for me. It's like that. These are two different systems, and which of course both have been grown historically. And while in Europe, the focus is more on the raw materials and on their migration, the focus in US is on the final materials, that they have to be listed, and that they now, meanwhile, it's a double system. So they look at the final polymers on one hand and make extractables, and they look on specific substances which need to be listed in regards of a food contact notification. But the system is different from the original approach and very much different in details. And what is clear is that you cannot take an FDA compliance and say, now you're in compliance in Europe, and vice versa. So European compliance does not mean that you're FDA compliant.
Okay. The next one, when talking about food contact time, the period and the temperature, is this what the manufacturer expects under normal use conditions? What about frozen food and storage containers?
Yeah, well, if you use storage containers, let me respond to that first. Is if you have repeated use, you can make 3 migrations in a row with every time changing the solvent. And if it shows up that the migration figures are declining, then you can use the third figure for compliance with the value given by with the SML given by the PIM. Important is why it should be shown that it's declining. It's because in some cases it could be that there is a degradation and that it's increasing. So that's why you need to measure all 3 values, but you can take the third one for compliance.
Okay. Then back to the first question in this line. What about the food contact time and period? Is this what the manufacturer expects under normal use conditions? So how to define the food contact time and the temperature?
Yeah, time and temperature, of course, these are things which are related to the end application. So if you know the end application, let's say it like that, as a supplier, then of course you can choose the material for it which you know that is compliant for 10 days 40 degrees or 2 hours 70 degrees. If you don't know, you usually take the so-called standard conditions. So standard conditions would mean a average storage time of below 30 days. So 10 days 40 degrees would apply.
Okay. GMP, next question. GMP, can the end consumer request documentation or only authorities?
Usually only authorities can see the supporting documents. Of course, it's a matter of relations, whether you want to provide more to your client or not, but you're not obliged to.
Okay. Then a question on NIAS. Who needs to perform NIAS studies?
Again, the crucial point at the NIAS is that the end product, so this means the end product is in this regard not the packaging. The end product is more or less the food, because you're not eating the packaging, you're eating the food, and the food shouldn't harm consumers' health. So it needs to be assured that nothing from the packaging could harm consumers' health. So it's in the hand of the end product producer or the packer. Of course, it's very much helpful to get documentation up the value chain, because up the value chain they got the knowledge on the product. They got knowledge which you don't have as an end packer. So you need to go into communication with your upstream supplier. And in many cases, I know the upstream suppliers, they are checking their product, whether it's harmful or whether it's harmless mollusk. That's what you want to check for.
Okay, next one. Someone who attended the previous webinar, modeling was mentioned. I expect this can be used, question mark.
Yeah, so there are two kinds of modeling approaches. There is a 100% migration calculation, which is the easiest one, and you don't need to know which plastic it is. You just calculate down, because usually the substance is given in milligram per kilogram polymer. So if you have 1,000 milligram in 1 kilogram polymer, this is 1,000 ppm in the polymer. But if you look at the EuroCube, you have a very thin packaging on 6 square decimeters. The weight of this packaging might be 10, 15 milligram, let's say 10. So of course, if you have 1,000 milligram in 1 kilogram, you have only a 10 milligram in 10 milligram in 10 gram of polymer. So only 10 milligram can migrate. This is the 100% migration calculation. So it would be then 10 milligram per kg of food. Then you can go to a more sophisticated step to use one of those available migration models, which you need to buy, which are costly, and which calculated the migration based on the diffusion through the polymer. And of course, polymer specific and substance specific temperature are the lipophility are the most important parameters in this modeling. This modeling shows a very realistic scenario of what is happening between the plastic and the food. Of course, it just can give the results with the input parameters you put into the model. So you need to be sure, and you need to know, for example, what is the residual content in the polymer.
Okay. Okay. Sorry, would you like to finish? Sorry, I may have interrupted you.
No, it's okay. It's okay.
Okay. The next one, I hope I read it correctly. The plastic handle on cutlery, is this falling in the scope? Is this intended food contact or foreseeable food contact? So it's the handle on cutlery, how to... So a metal
this is
with
a
a plastic handle.
Yeah. This is of course a very good question, and this is a borderline question. So not all things are necessarily clear. In this case, you can say it depends whether how the handle is. If the handle can reasonably be in contact with the food, you need to check it. Okay. And if you can see that it won't be reasonably in the food, then you not necessarily need to check it. This is a matter of your risk assessment, because here it's a matter of exposure. Usually, I would say it does not come in direct contact with the food. But when I would be a producer, I think I would do the testing.
Okay.
Just to be on the safe side.
Okay. I think we will go to the last one, and to all attendees, any open questions will be followed up after the webinar. Some people ask for the presentation. You will receive an abstract of the presentation of Dr. Tawara. Again, sorry for the poor sound. Going into the last question, are there any harmonized standards referring to overall and specific migration? So is there a harmonized standard for overall and specific migration?
Yeah. Overall and specific migration, they are handled in specific standards. I don't have the numbers in mind now, but there are for each of those, there are standards which you can use in the testing laboratories.
Okay. Well, still many open questions. It seems to be a hot topic. I think we need to finalize now. Thank you all for attending. Jürgen, maybe you would like to say something.
Yeah, thank you very much. Sorry again for the inconvenience. And what is important, this is the first webinar of a row of webinars covering specific points of interest, which we found out from discussions are more interesting in depth for our clients. And of course, we would be very grateful when you attend next time as well.
Okay. Thank you all for attending, and we are going to close down now the webinar connection. Bye.
Okay, bye.